Hey guys, hope you are well. This is going to be a fantastic lesson that's going to teach you a lot of interesting things. So in previous lessons, we've looked at some interesting things about circuits, such as this formula over here. We've learned about things in parallel. We've learned about things in series. And so now we are going to apply all of these different techniques and things that we've learned, and we're going to give you some values to work with. Okay, there won't be really like any big calculations, but that will be coming up in later lessons. But this lesson is going to be quite in-depth. We're going to be looking at quite a few different circuits, and so yeah, it's going to be quite exciting and a lot of valuable information. So let's begin. They tell us in this question that A1 is 4 amps. Okay, so A1 is 4 amps. V is 6 volts, so that's 6 volts. V1 is 2 volts, so V1 is 2 volts. Now, let's just talk about what happens here. So we know that electricity always flows out of this positive terminal, goes here, goes here, goes here. Now, it can't go up because it cannot go through a voltmeter. So it's just going to go through R1, through R2, and back to the beginning. So this circuit does not have any parallel parts. It's only in series, okay? Remember, series is when the current only follows one path. Let's write that a bit better. Only follows one path or one pathway, okay? So we know that in series, the current remains constant. So if the current is 4 amps over here, then the current will also be 4 amps over here, 4 amps over here, and 4 amps over here. So for all of these, we could just say 4 amps. Now they're talking about voltage. Now, we know that this formula here is really good. They tell us that to calculate the voltage of a battery, you must take the sum of all of the voltages in series plus all of the parallel branches. But now we don't have any parallel branches, okay? So we're just going to take the voltage of the battery is going to be equal to the sum of all of the voltages in series. So that will be this one plus this one, okay? So V1 plus V2. Now we can just say here V. Okay. Now we know that this is 6 volts, the battery, and we know that V1 is 2 volts, but we don't know what V2 is. So if you just had to work out V2, you would end up seeing that V2 is 4 volts. Okay. And so if the battery gives 6 volts, then 2 volts is used over here and 4 volts is used over here. So your battery voltage must always add up to your voltages, the sum of all the voltages in series. Okay. And so V2 is 4 volts. And then all of these we said was 4 amps. Let's try another example. So with this one, once again, we are only in series because current starts over there and then goes this way. Whoopsie, went a bit skew there. Goes this way and then goes through all of that and then goes like that. Okay, so we are only in series here. They tell us that A3 is 2 amps. So A3 is 2 amps. V is 6 volts. Okay, V1 is 2 volts. And V2 is 3 volts. So we know that because we are in series, current remains constant. Okay, so if A3 is 2 amps, then all of these are 2 amps because in series, current remains constant. So all of these are going to be 2 amps. The next question says, what is V3? Well, we know that to work out the voltage of a battery, we can use this formula, but there are no parallel parts. So we can just say that the voltage of the battery is going to be the sum means plus, of all of the voltages in series. That'll be V1 plus V2 plus V3. So we could say 6 is equal to V1, which is 2 volts, plus V2, which is 3 volts, plus V3. If you had to go work out V3, you would eventually end up with 1 volt. So this V3 is 1 volt. So can you see that the battery has 6 volts? And so we use the 6 volts over there. We use 2 over there, 3 over there, and 1 over there. So it all adds up to 6 volts. Here's our next question. As I said, we're going to do quite a few. We're going to do some parallel. We're going to do some combined circuits. So quite a lot of good questions coming up. Okay, so here we have a circuit, and it looks once again like it's just going to be in series. Okay, sorry, I just erased that by mistake. So it's just a series circuit. So they tell us that A3 is 1 amp. Okay, 1 amp over there. V1 is 2 volts. 2 volts. V2 is 3 volts. And V3 is 8 volts. Okay. Now it says, so it says determine the values of A1, A2, and A4. So if this is 1 amp, we know that in series, current remains constant. So all of these are going to be 1 amp. 1 amp, 1 amp, 1 amp, and 1 amp. So all of them would be 1 amp. Now they want V, which is the battery's voltage. But we know this formula over here. Sorry, this one. But now we don't have any parallel branches, so we can just say that the voltage of the battery is all of the voltages in series. That would be V1 plus V2 plus V3. So we could say 2 plus 3 plus 8, and that would give us, what is that? 13 volts. 13 volts for V. Here we're getting to a parallel part, so let's see what happens now. So if we use a highlighter, we start here, it goes this way, goes this way. Then what happens is that some of the current will go this way over here, and then the rest of the current would go this way. It would all join together again, and would then carry on like that. So this part over here is what we call parallel. It's wherever the path splits. So parallel is a place where the path splits. Okay, so let's have a look and see what they've given us. They told us that A1 is 5 amps. So that's 5 amps. We are told that V, which is the battery, is 4 volts. And we're told that A2 is 1 amp. Okay. Now, these questions say, what is A3 and A4? So if we look at A1 and A4, we know that in series, current remains constant. Now remember, this yellow part is in series. It's following one path. Can you see that? So whenever it's the same path, that's series. Okay? I know this part here is parallel, but the yellow part is still in series. That's not following. There's no path splitting of those parts, okay? So A1 and A4 would actually be the same because the current remains constant. So A4 is going to be 5 amps. Okay, now we've also learned that in parallel, the voltage of each pathway is the same. Another thing we've learned is that the sum of currents in parallel is equal to the current in the main circuit. Now remember, the current in the main circuit is this part. It's this part in yellow that I'm showing you. That is called the main circuit. It's the part that doesn't split up. Okay? So they tell us that the sum of the currents in parallel, so these two, is equal to the current in the main circuit. Now that's just a fancy way of saying that if you have 5 amps over here, so you have 5 amps going this way, then 1 amp goes this way. How do I know that? Because they told us that A2 is 1 amp. Well, that then means that 4 amps would have to go this way. 4 amps. So that when you add these together, it still equals 5. Because they said the sum of current in parallel, so sum means when you add them together, is equal to the current in the main circuit. So 1 plus 4 is 5. It's like having 5 friends. You and 5 friends decide to go to a shopping center, okay? And 5 of you are walking this way. One of you decides to go into the shopping center using that door, and the other 4 of you go through this door. At the end of it, you're still going to have 5 friends, right? And you're all going to be able to go into the shopping center eventually. So that's what's happening there. Now, so let's just go fill that in as A3 is 4 amps. The next thing is they want us to calculate the voltages. Now, we know that in parallel, the voltage of each pathway is the same. Okay, that doesn't help us right now because we don't know what any of these voltages are. The other thing we know is that this formula can be used at all times. So we know that the voltage of the battery is equal to all of the voltages in series, but there is no series voltages. Can you see there's no voltages in series? So we can ignore that part. So we can say that the volt of the battery is equal to the parallel branches. But we know the voltage of the battery is 4, so we can say 4, and there we go. Each of the parallel branches is now going to be 4. So that means that V1 is 4, V2 is 4, and V3 is 4 volts. You're not going to say that it's going to be 2 volts and 2 volts. No, that's not the way we've learned it. We've learned that to use, that if this is 4 volts, and there's no other things that are in series, where we can see this part, then the voltage of the battery will just be the same as the voltage of these parallel parts, and that'll also be the same as the voltage of that part over there. Okay, so V1, V2, and V3 were all 4 volts. Here's our next example. So if we look at the way that the current flows, it starts here and then goes this way, this way. Now it can't go this way because that is a voltmeter. This part is a voltmeter. So it'll go this way, and then it'll get over here. Then some of it will go this way, some of it would go this way, and then the rest of it would go this way. And then it would all join together again to go like this. So remember that this yellow part is series, and it's called the main circuit. That's your main circuit, and it's in series, okay? And then this part here is parallel. That's in parallel. So let's go on to some questions. They tell us that A1 is 6 amps. Okay, so there's 6 amps. V2 is 4 volts. So V2 is 4 volts. And A2 is 1 amp. Okay, 1 amp. And A3 is 3 amps. Okay, excellent. Now, they say determine the values of A4 and A5. Let's start with A5. We know that these two are in series. They're part of the main circuit. They're not part of different paths. So when they're on the same path, then they have the same current, because in series, current remains constant. So A5 would be 6 amps. Okay, so let's just say A5 would be 6 amps. So let's just go fill that in there. Now, they say find A4. Okay, we'll have a look at this, guys. You've got 6 amps of current busy going this way. Now, 1 amp is going to go on the green path, because there it is. 3 amps, are going to go along this way, because they told us that. So then the rest of it is going to go this way. We also know that the sum of currents in parallel is equal to the current in the main circuit. So what that means is that A1 is going to be equal to A2 plus A3 plus A4. And so 6 is going to be equal to 1 plus 3 plus A4. If you had to go calculate A4, you should eventually end up with 2 amps. So A4 is 2 amps. Once again, it's like having 6 of your friends walking up this way over here, and 1 of your friends goes this way, 3 of the friends go that way, so then 2 of them would have to go that way, so that you still have 6 people all together. So we went and worked out that A4 is 2 amps. Okay, now we're going to look at voltages. So we know that in parallel, the voltage of each path is the same. So this pathway has a voltage of 4 volts. So that means this pathway would be 4 volts, this path is 4 volts, and this is also 4 volts. So we could say that V1, V3, and V4 are all equal to 4 volts. Now, to calculate the voltage of the battery, we could use this part over here. So we know that the voltage of a battery is equal to the voltages in series, but there is no voltages in series. Can you see there's no voltmeters connected in series? So we can ignore this part. And then it says plus all of the parallel branches. But I've got a little star there to remind you that you got to do this one carefully. So when they say parallel branches, you only choose one of these. You don't choose all of them. So I'm just going to choose V1, for example, which is 4 volts. It doesn't matter which one you choose because they're all equal to each other anyways. They're all 4 volts. But the battery's voltage is going to be 4 volts. Now this question is excellent because it's got a bit of parallel, but then this part over here is a little bit more interesting. And so I think I've got another example. Oh yes, this one's also really good. Okay, and then after that we're going to start looking at some combined questions where we've got a bit of series and a bit of parallel in one. So this one's really excellent. So let's see the way electricity flows. It starts over here and goes like this and gets to this part. Over here, some of it will go up. So let's go up. some of it will go down, and then it will combine again to be part of the main circuit. So they tell us that A1 is 5 amps, V is 4 volts, V3 is 1 volt, A2 is 1 amp, A2 is 1 amp. Okay, so they say, first question, determine the values of A3 and A4. So let's start with A4. We know that in series, the current remains constant. And remember, this yellow part is part of the main circuit, and it's part of the same pathway, so it's series. When it's the same path, that's in series. When they go on different paths, then we call that parallel. So in series, current remains constant. So if this is 5 amps, then A4 is also 5 amps. So we could say that A4 is 5 amps. The next one is to calculate A3, which is over here. So we know that the sum of currents in parallel is equal to the current in the main circuit. So we could say that A1 is the same as the sum of currents in parallel, like that. And so we could say 5 is equal to 1 plus A3. So if you had to work out A3, you would end up with 4 amps. So A3 is 4 amps. Now this next part's going to get quite interesting. So now they want us to calculate all the voltages. Now, we know from this formula over here that the battery's voltage is equal to this part. So we could say that the voltage of the battery is equal to the sum of all of the voltages in series. But in series, we don't have any voltmeters. Can you see on the yellow part, there are no voltmeters. This voltmeter here is connected to the parallel part. Okay, so we're going to just ignore that part. And then it's going to say all of the parallel branches. So that's going to be all the parallel branches. So what that means is that all of the parallel branches are going to be equal to the battery's voltage, which is 4. So that means that this branch is going to be 4. So that means 4 volts for V2. And that means this branch is also 4 volts. But this voltage is already 1 volt. Oh, we don't need to calculate V3 because they gave us that. So this branch is 4 volts because that's what we've said here. So that means that V1 would have to be 3 volts. So that the total of this branch is 4 volts. Okay, and so there we've calculated everything. So here's our next example. So let's see the way electricity flows. It starts over here and goes like this, like this, like this. And guys, in future lessons, we are going to be doing the bigger calculations where we use formulas like I equals to V over R. We're going to be looking at that, okay? But you can't do those without these fundamental ideas or things that we'll be busy looking at. Okay, and then some of the current will go up, some of it will go down, and then the rest would go this way. So any path that is the same, such as the yellow one, that is part of, well, this part is the main circuit, and it's in series. That part is in series. It's only when it splits up, like over here, where we would say parallel. Okay, so let's see what they tell us. They tell us that A1 is 5 amps. So A1 is 5 amps. V is 7 volts. So the battery's voltage is 7. V3 is 1 volt. A2, where you A2, there is 1 amp. And V4 is 5 volts. V4 is 5 volts. Okay, so let's go calculate. They say determine A3 and A4. I'm going to start with A4. Can you see that A4 is part of the main circuit? So in series, current remains constant. So A4 will be the same as A1. So A4 is the same as A1, which is 5 amps. 5 amps. Okay. Then to calculate A3, well, we know in parallel, the sum of currents is equal to the current in the main circuit. So A1 is going to be, so the sum of the currents in here, so A2 plus A3, is the same as the current in the main circuit, which is A1. So this is our formula over here. So if we have 5 amps over there, A2 is 1, then A3 you could calculate, and you would get 4 amps. So that means A3 is 4 amps. Should make sense to you. If you have 5 amps entering, 1 goes that way, then 4 has to go the other way. Okay, let's go look at the voltages now. So we know this formula, okay? So we know that the voltage of the battery is equal to all of the voltages in series, but there are no voltages in series. In future examples, in this next example that we're going to do after this, we will look at voltages in series, but for this one there are no voltages in series, so we're just going to ignore that. Then we're going to say it's going to be equal to all the parallel branches, so we're just going to say this. Now, we know that the voltage of the battery is 7. So that means all of the parallel branches are going to be 7. So that means V5 is going to be 7. So V5 will be 7 volts. And then this whole branch would be 7 volts. And this whole branch will be 7 volts. But in this branch, we already have V4 as 5 volts. So that means that this one would only have to be 2 volts because 2 plus 5 is 7. So V2 would be 2 volts. Now, this entire branch also has to be 7 volts. And so that means V1 would have to be 6 volts. So V1 would have to be 6 volts. So that this branch is 7 volts and this branch is 7 volts. Here's an amazing example because it's going to have a little bit of series combined with a little bit of parallel. And then we've got, I think, one more example. Oh, and then there's another one and another one. Okay, so we've got about 3 more examples. Excellent. So if we follow the electricity, it goes out of there and then goes down this way, goes through there, up here, up to there. Some of it would then go this way, some would go this way, the rest would go this way. They would all combine again to join the main circuit and go to there. Okay, so they tell us that A1 is 6 amps. Okay, A1 is 6 amps. V2 is 4 volts. V2 is 4 volts. A2 is 1 amp. Where's A2? Here it is, 1 amp. V is 9 volts. The battery is 9 volts. And sometimes they'll call the battery the EMF. Okay, and then A3 is 3 amps. Okay, so now they just want us to go calculate a whole lot of stuff. So they want us to calculate A4 and A5. I'm going to start with A5. Now, these two have to be the same because they're both part of the yellow part, which is the main circuit. So we know that that series and in series current remains constant. I really hope this stuff's becoming repetitive for you. So A5 is going to be 6 amps. The next one, A4. Well, we know that the sum of currents in parallel is equal to the current in the main circuit. So the current in the main circuit is A1, and that will then be equal to the sum of all of the parallels, so A2 plus A3 plus A4. So we can say 6 is equal to 1 plus 3 plus A4. If you then had to go calculate A4, you would get 6 take away 4, which is 2 amps. And so A4 is 2 amps. Okay, so that's all the currents done. Let's just put 2 amps over here. Now it's the voltages. Okay, so we know now this is where things are going to get super awesome. I'm excited for you guys to see this. Okay, so we know that in parallel, the voltages of each pathway is the same. So if this one's 4 volts, then that means this is 4 volts, this is 4 volts, and this is 4 volts. Okay, so we can immediately say that V3, which is the same as V4, which is the same as V5, is going to be 4 volts. So all of those are 4 volts. Okay, but now we've got to try to calculate V1. So now we're going to use this formula. This formula here. So we know that the voltage of the battery, now here's where things are going to be awesome, is equal to the sum of all of the voltages in series. So the voltages in series is only this one, so we're going to say V1. Then it says plus parallel branches, but remember with the parallel branches you only choose one. So I'm just going to choose V2. You choose any one that you know, so I'm just going to choose V2. But you could have chosen V3, you could have chosen V4, or you could have chosen V5. And so the voltage of the battery is 9. So we're going to say 9 equals. Now V1 we don't know. And then I'm going to choose V2, which is 4. And so if you had to go work out V1 now, you would say 9 take away 4. And so V1 is 5 volts. V1 is 5 volts. Okay, here's another example. So I'm not going to go do all the highlighting now. I think you guys are starting to get it. So they tell us that A2 is 6 amps. 6 amps. V2 is 4 volts. V2 is 4 volts. Okay. A3 is 1 amp. 1 amp. Got it. and V1 is 2 volts. 2 volts. Okay. So now and then A4 is 3 amps. A4, where you 3 amps. All right. Now they say determine the values of A1 and A5. Okay, so A1. Well, we know that the sum of currents in parallel is equal to the in the main circuit. So A1 is equal to all of the parallels added together. So that would be A2 plus A3 plus A4. So we could say A1 is then equal to 6 plus 1 plus 3. And that is going to give you a total of 10 amps. Okay, so A1 is 10 amps. But now, if we quickly use our highlighter, we should realize that the main circuit is over here. So that means that A1 and A5 must be the same, because in series or in the main circuit, current remains constant. So A5 is also going to be 10 amps. Okay, let's move to this part now. So they want us to calculate all of these different voltage values. Now we know that in parallel, the voltage is the same. So if this voltmeter says 4 volts, then that means this is 4 volts, this is 4 volts, and this is 4 volts. Okay, so that means that this one is 4 volts, this is 4 volts, and this is 4 volts. Okay, so we've answered that question, and that question. Now we just have to go do this one. So we use this formula. So it tells us that the voltage in the battery is equal to the sum of all of the voltages in series. So that'll just be this one, plus the parallel branches. But with the parallel branches, you only choose one of those parallel branches. So I'm just going to choose that one. So you could say 4. And that's going to end up giving you 2 plus 4, which is 6 volts. So this is a 6 volt battery. 2 more examples, guys. Just this one and this one, and then we're done. Well done for getting this far. So in this one, they tell us that ammeter 2 is 6 amps, okay, and V5 is 3 volts. V5 is 3 volts. There you are. A3 is 1 amp. A3 is 1 amp. And V1 is 2 volts. And A5 is 10 amps. A5 is 10 amps. Now it says, determine the values of A1. Okay, now if we look at this part of the circuit, that's all part of the main circuit, and then it would carry on over here. So we can see that any part that is on the same path has the same current. So this one and this one are going to have the same current. So A1 is going to be 10 amps. Now, the next question is all about the voltages. Okay, so we know that this voltage is V5. Now, it says that in parallel, the voltage of each path is the same. So that means V5, V4, V3, and V2 will all be the same, and that would be 3 volts. So that's 3 volts, 3 volts there, and 3 volts there. So we've done all of that one. Oh, V5 they gave us. Okay, so now they need us to calculate this voltage, so we use this formula over here. So the voltage of the battery is equal to the sum of all of the voltages in series. So in series, which is the yellow part, we just have this 2 volt, okay? And then the parallel branches, but you only choose one of them. So I'm just going to say 3 volts over there, because they'll all be the same anyways. But you don't add them all together, you just choose that number, and that would give you 5 volts. So this is a 5 volt battery. Alright, so I just realized that this next example that I was going to do with you, which is going to be this one, I don't know why, but I actually duplicated this. This is the exact same example that we did over here. So we don't need to do that one, so we are actually complete.